Okay, hi guys. This is a type of question where you get given a graph printed out for you, and you are expected to solve an equation using that graph and your ability to draw lines. So the first thing we need to take account for is, what is the equation that you are asked to solve? Well, it's given on the page here, and also you need to know what equation your graph has, and there it is. That's the equation of the graph that we've just seen. So we have to make the left hand side of the equation that we want to solve look like the horrible stuff in the equation. And what we notice when we do this is we have x cubed, well that's the same, so we don't want to change that at all, minus 2x. Well, that's the same, so we're not going to change that at all. The minus 6, however, is wrong. It's a minus 2. So what we have to think about is we want to try and make x cubed minus 2x minus 2 equal, and we don't know what the other side is at the moment, but we have to think about what it is that we're adding or subtracting to minus 6 to get our number minus 2. And so a little bit of thought will help you recognise that we have to add the number 4. So if we add 4 on one side of our equation, we're going to add 4 on the other side too. So if we add 4 on the right hand side, we get the equation x cubed minus 2x minus 2 equals 4. Now, as you're going to see from the next few examples, this thing is really important. Whatever it is, it might have x's in, it might just be a number, it might even be 0. Whatever it is, we make y equal it. So that number goes there. And we have to draw this line. Okay, now the line y equals 4 is the horizontal line that goes through the y-axis at 4. So let's draw it. Okay, and that's the line. Now we look for where the line that's already been plotted on our graph paper crosses the line that we've just drawn. And so we're going to focus on that point, and what we want to know is, what does x equal at that point? Well, if we go down and read off the x coordinate, what we get is x equals, now it's very faint on this video, but we're seeing x equals 2.2. There's 5 little kind of tiny lines. They're very faint, and I'm not expecting you to read perfectly what they are off this video, but reading the x coordinate is the idea. So this is our solution to the equation, which should just appear on the screen now. So there it is. So that is the solution to this equation, and we've used the graph to find it. Okay, so in this example, what we're seeing is a different equation. We're going to be solving a different equation. It's still got features that are similar to the graph, like the x cubed and the x cubed are the same. However, it's a different amount of x. We're going to deal with the different amount of x first, and then we're going to deal with the fact that this is minus 1 and not minus 2. Each time you do this, you have a target, and your target is the equation, the stuff on the right-hand side of the screen, the parts of the graph with just x in. So x cubed minus 2x minus 2. And that's equal to something. You don't know what that something is yet, but you are working from the equation you're trying to solve and you are working down to this. Now, first of all, if I've got minus 4x and I want to get minus 2x, I'm going to have to add 2x. Now, you're adding together of positive and negative numbers. That needs to be spot on with this. So let's just check this out. Minus 4, add 2, makes minus 2. Perfect. Now, we're doing that to one side of our equation, this side. So we have to do it to the other side of our equation as well. So I'm going to write that in next. Okay, so that's the 2x sorted. What I also need to look for is getting this minus 1 to be minus 2. And the thing I have to add to both sides is going to be minus 1. Now I've got minus 1, add minus 1 equals minus 2. I have to take away 1 from the other side because I am doing the same thing to both sides. So now if I add the right-hand side, all of this stuff up together, I get 2x minus 1. Now it's the same thing as before. We have to take this thing and make y equal to that thing. And we have to draw this line. That's what we're going to do next, and that's why you've got the graph. Now the key thing here is we have the gradient and we have, in this blue box here, the y-intercept. Now we're going to draw this line fairly quickly by starting at the y-intercept and making a line from there that has a gradient of 2. So that's what we're going to do, and we'll move on now. Okay, so the y-intercept was minus 1. That's where we're going to start, and we want our line to have a gradient of 2. Now, if I move 1 to the right and 2 up, this line has now got a gradient of 2 because I've gone up by 2 and along by 1. So you go along 1 and up whatever the gradient is and put a dot. You do the same again and the same again. And you can see the straight line emerging. You work backwards and that's the line that we get. Now this is drawn on an iPad, not using a ruler, so I want you to be forgiving. Oh, that's not bad. Okay, that's our line. We're going to circle the points of intersection there, there, and there. Now, they are quite difficult to read, but we look for the x coordinates. What does x equal there? What does x equal there? And what does x equal here? So if we again, those lines are not straight, but we are using those values for our solutions. So we're going to have 3 solutions. One of them is going to be x is equal to 2.2, or really close to that, and that's this one here. Then we're going to get x is equal to about, see, that's a really difficult one, minus 0.3. It's negative, and it's looks like it's halfway into the second box. And then the very final one is x is equal to minus 1.8, or thereabouts. Again, it's this one here, just so you can see which ones they are. And those are the 3 solutions to the equation that will pop up on the screen at the bottom. Okay, so they are the solutions to this equation, and we are finished with the question at that point. Okay, the last question on the examples that I've set you for work is actually a bit of a trick question. So far, you've added or subtracted your x terms Oh, hang on. Let me undo that. Your x terms or your constant terms to get the graph. Now, that's not actually going to help us here, because one of the things we tried to start doing in the classroom was this, taking away x squared, adding x, and then adding 7. And doing that to both sides. Ooh, crikey, excuse me. That should be a cubed, and that should be a 2 in front there. And if we do that, what we're going to get is x cubed minus 2x and minus 2. However, the other side of the equation needs to have minus 2x cubed on it, and a plus x and a plus 7. So what we get is this. Now that is not fun to draw. We do not want in fact, you only want straight lines. And the reason I know that's not a straight line is because of this character here. 2x cubed is non-linear, is what we call it, so it's not going to be a straight line. So we have to find another way. So I'm going to get rid of all of that stuff. Let's go. Off you go. This doesn't work, so we're just getting rid of it. And we look to notice something very special about the 3 terms in the equation that we're trying to solve. The special thing that we're trying to notice is that each of the terms has a factor of 3 in, and this is 0. So what we can do is divide everything through by the number 3, and that's what we're going to start by doing. We're going to divide everything by 3, giving us x cubed minus x minus 3, and that's still equal to 0, because if you have something that's equal to 0, you divide it by 3, it's still equal to 0. At this point, the important thing is that we've got the same number of this x cubed in both, so we're not going to need to do any extra work with the x cubed. So x cubed is still there. We now want minus 2x, and we want minus 2, and we have to figure out how to get there. So I deduce that I need to take away another x to get to minus 2x. I need to add 1 to get to minus 2 from minus 3. So on the other side of the equation, I have to minus x, and I also have to plus 1. So this, that was an accidental mistake by your teacher. Let me show you what it is. I put the 0 in there, and I should have no right to do that. I need to get rid of it. I'll leave the equal sign. But what I should be adding together to get that side of the equation is all of this stuff here. And what that's going to give me is minus x plus 1. So I need to draw y equals minus x plus 1. So for this equation, the gradient is minus 1. It's what we multiply x by, and it just says negative x, and that's the same as multiplying x by minus 1. The y-intercept is positive 1, so that's where we're going to start at positive 1. And then we go along 1 and up the gradient. But since the gradient is negative, we have to go down by 1. Along by 1, down by 1. Along by 1, down by 1. This line has a gradient of minus 1. That's why we go along by 1 and down, because it's negative, and only by 1 because it's negative 1. If it was negative 2, we would go down by 2. Negative 3, we would go down by 3. Okay, now I can see my single solution to my equation sits about there. It's around, let's actually kind of go up there. I think we're looking at x is equal to 1.6. I'm not really fussed if you get 1.7 or 1.5 or 1.8. If you misread, or if like it's difficult to read the x-axis here, that's not really something that will bother me. It's more to do with, have you drawn the line correctly, and have you tried to read off the x-coordinate? So that is the last solution, and you will see the equation appear on the screen shortly. Okay, so x equals 1.6 is the only solution to our equation. And we're solving these graphically. That's what makes this tricky. Okay, guys, I know you've been off all week and like you haven't had a huge amount to do. This topic is extremely tricky to teach remotely, so I hope you don't mind me waiting till a bit later. And both of you, if you need extra help to understand the topic, I'm prepared to give up some time for lunch times just to help you catch up, because I know you're both so hardworking. It's not really too much of a bother.